everyone, my name is Sonja, and today I'm going to give you a tour of the lab that I've been volunteering in, the Wong Lab. So right now we are on campus. Let's see, over here is the science library, and then over there is the entrance to Klamath Hall. So the Wong Lab, because it's a laser and optics lab, is actually in the basement of Klamath Hall. So we'll be starting out in the prep lab and then moving our way through, and without further ado, let's go. So this is the prep lab space. The prep lab space is where we enter and get on our PPE, and sometimes we do work in here. There's a fume hood. So I'll just show you all. There's the entry. There's the door to the laser lab, which we'll be headed into. And then over here is the fume hood. So right there we can do work with chemicals if we need to do work. So the first and most important part about being in lab is putting on PPE. So what is the PPE that I wear? I wear a mask. I wear gloves when I'm working with either chemicals or optics. Chemicals to keep me safe. Gloves when working with optics to keep the optics safe from my pans and oils and whatnot. So this is my PPE. First off is the lab coat. Lab coats are important when you're working with chemicals and just working in the lab in general, and are just an extra layer of protection in between you and whatever you're working with. So, yeah, and whoop, drop something. All right, and the goggles are also very important, eye protection, and you're required to wear them when you're working with chemicals, and it's just good practice to wear them wherever you are in lab. All right, so now that I'm suited up, let's head to the laser lab. So now we're in the laser lab. The laser lab is where we work with both optics and the laser. So I'll show you all the laser. The laser is a high-powered laser that we use for measuring changes in chemical systems. So particularly films right now, but also generally chemical systems. So this is the laser table, and it's quite big, as you all can see. The laser kind of starts from this complex right there and goes through here, and this seems like a lot of optics, but it hits pretty much every single optic there. We've got mirrors, we have prisms, and then it goes down there, and then all the way to here, which is where we actually take the measurements. I mentioned films. So what do films look like? This is an example of a film. Get back on my glove here. So this is one example of a film. You can kind of see it's on a glass slide. This one was drop cast. So yeah, which means we take a pipette and we pipette it onto the slide and let the solvent evaporate, and we're left with this. I showed you all the laser table and the laser kind of complex. But over here is the microscope setup that I worked on for the first part of the summer. So I worked with a senior undergrad named Maddie, who graduated and went to grad school at MIT. And we worked with this microscope, and you may say, that doesn't look very much like a microscope. But it is. So the camera is up here, and there are lenses and a polarizer that's on a rotating mount, and then the lamp, so where the light starts comes here, and light comes there, through these optics, and up to the camera. And where we measure our sample is right there. So we were measuring organic thin films, and then I was mostly making the thin films in the wet lab, which I'll show you all next, and then measuring them with this microscope setup. And then Maddie wrote a Python program and used that program to quantify the different features of the films. And yeah, and then used that to tell how the deposition conditions were affecting the final features of the films. All right, so now we are in the wet lab. The wet lab is actually a shared space. So both the people from the Wong Lab, the lab that I'm with, and the Prel Lab, another lab here, share this space. So you'll see there's kind of a divider. The Wong Lab stuff is over here, and the Prel Lab stuff is over here. And the Prels work with mass spectrometry with proteins and nanodiscs, in case you were curious. So I'm going to be showing you all the stuff that I'm currently working on. I work primarily in the wet lab, and I'm working on the lead perovskite nanocrystal project. So what is the lead perovskite nanocrystal project? So in this project, we are synthesizing, which means just combining the ingredients of and making lead perovskite nanocrystals, and then we measure the absorbance and fluorescence. So to synthesize them, we combine all the various ingredients into a vial in the sonicator, which is right there. So we use foam to kind of float the vial, and then we have the sonicator going, and the sonicator mixes it up without us having to mix. It's very convenient. So we weigh out everything, mix it up, and then we withdraw a certain amount using syringes right here, and then filter that through the syringe. So we filter that through the syringe into a cuvette. So cuvettes are those things. I would pick it up, but I'm not wearing gloves, so I really shouldn't touch anything here. So once we have cuvettes of our nanocrystal mixture, what do we do with them? So we load them into this instrument, which I'll admit, when I first saw, I thought it was just a box of optics. And it kind of is. But this measures absorbance and fluorescence. So there is a laser, and when the laser is on, it bounces off these mirrors, and the cuvette is loaded in right here. And then this one measures absorbance. So it measures how much whatever is in the cuvette absorbs the light that's coming in. And then, so that fiber optic cable measures absorbance, and this orange fiber optic cable measures fluorescence. So how much light the object is emitting. Yeah. And so once we have that data, we can work with it to see how the different ways that we make the nanocrystals alters its properties, and how its properties alter over time as it's growing. So specifically, we're looking at how the nanocrystal changes from just a combination of all the starting materials to the final nanocrystal, and what the different components in it are doing, and we're using absorbance and fluorescence as a way to see that, and to see what's happening at the molecular level. So just to show you all a few more things in this wet lab, we have our storage of chemicals. This is our storage of smaller chemicals and more volatile chemicals. I believe it's a nitrogen box, so it's filled with nitrogen to keep the oxygen from interfering with anything. And then we have, over here, we have our lead soap. So because we're working with lead, we want to be really careful, and this soap is a type of soap that is specially made to remove lead from people's hands. We also have our sharps box because we're working with syringes, and so we want to have somewhere safe to store that. These counters, just for more work. And then finally the fume hood. Fume hood, very exciting. Over here is where we store our organic waste and our other aqueous waste. And then right now we've got some hot plates in there. One of the grad students here at the lab, Michael, was using those hot plates for a nanocrystal synthesis. Underneath the fume hood, we have where we store our organic solvents. So I put on a glove just to be absolutely safe. And in there you can see, all of our organic solvents. We store them under here because it's fireproof and explosion proof, hopefully, and just safer. All right, so I think that's everything. I've showed you the prep lab, showed you the laser lab, and finally the wet lab, where we are right now. This research has been really cool. So the research that this lab in general does has a lot of different applications. It's really, so the nanocrystal stuff specifically is working towards developing better LEDs, more energy efficient LEDs, and lasers. And the thin film electronic stuff that I showed you, the films that I showed you briefly, is working towards developing better solar panels. So it's really cool research, and it's been awesome for me to have the opportunity to join these people and work with grad students and other undergrads. And I would highly recommend for you all to get involved in research. Talk to various professors, ask them if you can take a tour of their lab or shadow them for a day. It's super cool, and it's been such an awesome experience to work in an actual professional research lab, doing actual research with the potential to help people. And it's been really awesome for me. Highly recommend it. Thanks for coming, everyone. I enjoyed showing you around. Bye!